We're going to use some butane for the To the best of my knowledge, that doesn't violate any Jewish dietary. Now, if the experiment works, and it really is a genuine experiment, what's going to happen is that the potato is going to shoot through that stream and be sliced into delectable fry-ready pieces. In case you're wondering how fast our potato is going, we can look to this genuine article, which was submitted to the archives last year. It was brought to my attention by Greg Engel, who is an expert not only in obscure mechanical effects like the Latke potato duality, but also in firearms. He's also Beam's advisor. You can see from the graph taken from the article that with butane, probably our potato was only moving at about 1/10 the speed of sound. If you really want it to go, you've got to use acetylene. Not to be outdone by this study, I want to perform my own experiment for the Hamantash. The component of a Hamantash, the materials property most similar to a potato, is the dough. However, I was concerned that the dough would stick in the barrel, causing an explosion that would terminate not just the experiment, but also the experimentalist. Let's search for coefficients of friction for potatoes and dough. Our library, anticipating the introduction of engineering to the American Society of Agricultural and Biological Engineers. And there I found a real article that reported on coefficients of friction for potatoes. However, I couldn't find analogous measurements for dough, despite a discussion of its properties in industrial mixes. Might I add that if you actually read that abstract, you'll see that the contacting surface matters. And so I can make my own measurements for PVC. You can see that the angle of repose for the dough is quite a bit higher than for the potato. And so the sticking issue is a real one, and our only choice is instead to use an assembled Hamantash. Let's try.